Welcome to another episode of the All Turtles podcast, a show about entrepreneurship and AI. I'm John Cifuentes, co-founder at All Turtles. Today, Jessica Collier and I interview Austen Allred. Austen is the co-founder and CEO of the Lambda School, which is a coding academy that provides free training in exchange for a percentage of students' future income for 2 years. Austen talks about how this model has helped efficiently move people from low-income to high-income salaries. Then, Phil Libin joins Jessica and I to give some advice to entrepreneurs about product development. We also answer a listener question about personalization. So we're really excited to be joined by Austen Allred. Austen, thanks so much for coming in. Austen's the co-founder and CEO of the Lambda School.
Yeah, thanks for having me.
Hi, Austen.
Hi.
So can you tell us just what is the Lambda School? You know, we've talked to kind of other similar sorts of organizations on this podcast even, you know, so we're excited to hear from you and hear what you guys are doing.
Yeah, basically we train people to be software engineers and data scientists and UX designers for free in live online classes in exchange for a share of people's future income for 2 years. So they only pay us if they get a job that pays more than $50,000 a year in the field that they studied. Otherwise, we don't get anything.
So what's the origin story for this school? Like where's the kernel of the idea? You know, why is this your thing that you're, you know, dedicating your life to now?
Yeah, I mean, so I was living in small town Utah before I came out to San Francisco. And I mean, there's a whole lot of really smart people out there that are kind of trapped because there's not, you know, unless you want to go $100,000 of student debt and 4 years of college, like there's not a good option. And so they're making, you know, $30K a year doing whatever is there. Contrast that with San Francisco, where, you know, we're paying $10,000 referral bonuses for engineers. And just seeing that contrast, it was like, man, there's just such a huge disparity in the opportunity afforded to people. And I, you know, kind of got lucky and ended up on one specific path, but there's not a clear path to follow that. And I mean, I had to move out to Silicon Valley. I lived in my car for a while and broke my way into startups essentially. And I don't think that should be required of everybody to, you know, make their way in an industry that pays well.
I feel like Silicon Valley in particular tends to celebrate people who are self-taught, right? Who have no formal education or training in the thing that they somehow end up doing, magically making six figures. So how does the Lambda School sort of compare to like being self-taught, to teaching yourself to code or teaching yourself to sort of design?
Yeah, I mean, so I think being self-taught is really valuable because it comes slowly over a very long period of time. What we want to do at Lambda School is speed that up and get you into industry where you can keep learning and be paid to keep learning as quickly as you can. So I think the level of rigor and discipline to self-teach over the years is just insanely high. And I don't want to say there are very few people that can do that, but I think there are very few people that have the resources and freedom to dedicate enough time and effort and energy to that. So at Lambda School, we basically just tried to take out steps. How can we efficiently move people from low income to high income and get paid for doing so?
I think that's a really good point. Just the freedom to be able to do this. Like if you're, you know, working a low hourly wage in San Francisco, you're strapped. Like you're struggling, and you know, having the self-discipline or not isn't really in question. It's just the opportunity, frankly, isn't there. Right.
I mean, our average student comes into Lambda School making less than $40K, and no matter where you are, if you're and the average student is kind of late 20s, early 30s. They've usually have families and they've got responsibilities,
which could be fine for rural Utah.
Yeah, I mean that's not bad, right? And it depends. We have, you know, but we've got people who've been working in warehouses for minimum wage for years. Like it's really hard to be self-taught when you come home and you're spent, and there aren't very many good options.
Right.
So I think that you've always been able to break your way into industries, but it's just really hard, and it doesn't need to be that hard.
So I alluded to this in the opener, but we've had past guests on this podcast. Kwame, I'm going to butcher his name, Yamgnane, sorry, Kwame, from 42 Silicon Valley. and Sylvain Kalache from the Holberton School.
Yeah.
So how are you guys the same or different? Is this part of a general movement, or are you doing like a really specific version of this?
Yeah, I do think it is part of a general movement. The big difference between us and 42 or Holberton is we're entirely online. So we've got students in 48 states right now. And I think both of those guys would agree that the difficult part of attending 42 or Holberton is moving to the Bay Area,
Right.
Especially if you have a family or any level of responsibilities. I think 42, as much dorm room space as they have, they'll fill it up instantly. But getting people to live for a couple of years in San Francisco on their own dime, that's not a trivial ask. So yeah, we're just online.
That's really cool. Can you talk maybe why programmer education is kind of specific and different from traditional college? Like what you would learn getting a degree in computer science versus going to the Lambda School? Like, talk more about this general movement. Is there kind of like a pendulum swing back to trade and specialization, and it's just it just happens to be tech and coding?
Yeah, so I think there are kind of a couple intersections happening. So if you look at tech education specifically, we've gone from a computer science degree, which is very theory and a lot of depth, but not super practical. I mean, we see if you hire a computer science grad that hasn't been building their own side projects or, has had internships, you kind of have to, we've seen everything from, hey, here's Git, like here's JavaScript. Like it's great that you can write Scheme, but we need to build production applications now. And there's a whole skill set involved in doing that. And so the bootcamp movement came along and it said, we're just going to teach you JavaScript and maybe Rails, and you won't have that depth. You won't understand the theory. You won't understand how operating systems work. You won't understand, computing fundamentally. But you can build apps, and maybe in this day and age, that's all you need. I think there's kind of a glut of those folks now who can, build a simple application but don't understand why it works. So we're trying to find kind of that sweet spot in the middle where, we teach computer science, we build operating systems, we write a lot of code in C, but you also know how to show up day one and ship production code and work in a team and use Git and deploy to the cloud. And, just kind of the perfect combination of the two. And, so we're 9 months long full time, where most code schools are 12 weeks or, 2.5 to 3 months. So we specifically work backwards from, and this is how we're different than the traditional university system. We start with employers and we start with, what do you need engineers to know? And then we're going to work backwards from that to build a curriculum to get people to that point. And we're not, we don't have generals. We're very specifically trade career oriented.
You can be very specific and trade oriented because you're sort of operating on this. I think it's called the ISA model. Is it the income share agreement model?
Correct.
Right. So you are incentivized to train your students in a way that they can go out and find jobs that will give them a salary that's high enough so that the Lambda School gets paid back. Is that right?
Correct.
So I think I'm so intrigued by the ISA model, and I know that it's been a little bit controversial. Can you talk a little bit about the controversy around this model of financing education and why you sort of landed on this as your model?
Yeah. So, I mean, if you look at most of the controversy comes from the assumption that the ISA model will replace or eliminate some element of the liberal arts education that we've all come to know and love. And there are people that say, if we have Lambda School, then why do we need federal funding for universities or whatever else? So I think a lot of the criticism comes in that vein, where I don't view us as a replacement for a university. I view us as a very specific, we're a trade school, we're a vocational school. I don't think that Lambda School existing, it says anything bad about a liberal arts degree or says that need not exist. I just think there's a time and a place, and there are different circumstances for everything and everybody, and that different people will make different choices at different times in their lives and career. The other controversy is just that because our income is tied to the outcomes of students, that we will be investing in the students who are most likely to be successful. If you know anything about Lambda School and our mission and how we operate, you'll see that, we're not just trying to pick the top 1% of Ivy League grads and send them, add a tax onto what they're doing. We really are moving people from, warehouses and stocking shelves at Walmart to being a software engineer. So that one doesn't bother me as much. So the two complaints are basically, well, you're not a liberal arts degree, which I wholeheartedly agree with. And then you're going to be incentivized to pick the top, sliver of society and leave everybody else behind, which I think is frankly just a misunderstanding.
How do you remove bias from your selection process?
So we do everything entirely. First of all, our interview is phone driven, so we don't ever see you face to face. We do our best to be as unbiased as we can in that degree. But the vast majority of our application process is pre-coursework. So we put you through this completely free class. I mean, we'll ship you a computer if we have to. Try to make it as meritocratic as you can. Obviously, we can't get all the way there. People have different life circumstances. But most of our selection is based on how well you do, how disciplined you are in this pre-coursework. And the pre-coursework has a steep learning curve. And if you can make it through that pre-coursework, there's a very good chance we'll accept you. We don't look at your work history. We don't look at your educational history at all, which is very non-traditional for most, boot camps or vocational schools. We just try to find untapped potential and invest in and train that.
What does the demographic of people who have applied look like at this point? So I imagine how many people have gone through the program? Yeah.
So we don't share numbers, but we're over 1,000 students enrolled right now.
So something statistically significant, some large amount of people that you spend a lot of time with.
Mm-hmm.
And then, presumably some bigger mass having applied.
Mm-hmm.
Like what is it? Is it kind of like every slice of human across the United States? Is it worldwide? What's the...
Yeah, so we're in the United States and the EU right now. We are over-indexed to minorities in almost every way, except for women. For some reason, we only have 20% of applicants are women. I think right now it's 30 to 35% of accepted students are women. So we're trying to figure out, it's one of those things where the more we try to bring more women into the program, the more it brings in more men.
What are some things you've tried?
What are you doing to generate demand?
A lot of it is just how you target your advertising, how there is a whole lot of imposter syndrome that we see when we talk to women, that they've been told by somebody at some point in their life that,
or just society.
yeah. I'll lump all the somebodies together as society that, software engineering is not for women for one reason or another. So I think the biggest cohort that we're missing are women that just don't bother to apply. Once we get them into our application funnel, it's pretty, fair process. But yeah, finding and reaching those groups that are trying to empower women is not, it's a difficult challenge. Then the other way that we over-index to low-income students pretty drastically. That's not true across the board, but we over-index to rural slightly, and we over-index to, the similar demographics that map to being lower income. So very heavily racially diverse. I think for a long time we had more African American students than we had white students, which is not standard for a normal code school. But yeah, over-indexed to rural, over-indexed to lower income, over-indexed to minorities, generally speaking. That's, it depends on which state you're looking at and how you slice the data, but as an entire student body, that's what you're looking at.
And you mentioned that all of the courses are online, so people can join from anywhere. Do you have people from outside of the United States?
So because we use an income share agreement, that's tricky.
Right.
We have accepted some students, for example, from India or Southeast Asia, kind of as tests, just to see, if we train this person, can we place them? And if we can do that, then we'll go establish a framework for making that work in that country. So we're looking really hard at India and Southeast Asia, Singapore, those type of areas right now. If we can train a student in India, they're hired within 48 hours usually. So we're not there yet. There's a lot of regulatory and kind of financial infrastructure that we rely upon in the United States that doesn't exist in other places. But we'll get there.
I come from a pretty rural town where a lot of people, are quote left behind. I think, Jessica, you too. And I can look across my network of those people, feeling kind of disenfranchised or left behind or just like not having the skills. But for the people that do apply and that do well on the pre-work, what are some of the kind of inherent qualities that you guys have identified? Is it math and logic and reasoning? Like what are the cognitive skills that people need to do well at this?
Yeah, it's difficult to say because you never know of the people that don't make it through the pre-course work. You're never entirely sure how many people are opting out and why versus is it just the level of rigor that's too high? Is it this, they can't dedicate enough time? So that's always difficult. I would say overall, if you could give me a human of average intelligence who is exceptionally gritty and dedicated, I can get that person a job every single time, every time, barring crazy financial life circumstances that might get in the way. But yeah, I think that by far is the most important trait. Maybe if we were in the 50s or 60s, you would have to have some ridiculous level of IQ or analytical ability. But, in today's programming environment, there's not being able to write C and anything above that in the stack is pretty doable by somebody with an average level of intelligence. So I think more than anything, it's just determination and grit.
Well, one thing you mentioned in the curriculum is teamwork, and being that it's remote and entirely online, that's interesting. I mean, that manifests in how a lot of the people in All Turtles and how we work. But how does that work for the program? How do people collaborate on projects?
Yeah, I mean, if you asked 10 Lambda School students what they appreciate most about Lambda School, probably 8 or 9 would say the community. So even though it's online, it's still live, it's synchronous. You're working with a group day in and day out. You're building projects on teams. So you're collaborating in an online environment, but it's still just as collaborative as working in the same room would be. In fact, at times a little bit more so because it takes a little bit extra effort to make that work in an online world. And we had to build our instructional design around that. You can't just take a classroom and put it online and have it work. The same way, honestly, I'm not sure you can take a workspace and put it online and have it work. You have to build in extra systems and protocols and habits to make it work. But yeah, I mean, our students are with somebody literally all day. So you're never just off on your own coding for hours at a time. You're working with other people.
Can you talk a little bit about some of the instructional design decisions that you made? I'm like so deeply interested in how you take traditional pedagogy and move it so that you can distribute it across like a remote group of people.
Yeah. So, I mean, first and foremost, we break up so we have cohorts that are as big as 100, 150 at a time. We break them up into groups of 6 to 8, and each one of those groups has a paid full-time mentor who is there. So first of all, it's just expensive. And those small groups, they work the same way a company would, where we have sprints and they have a daily stand-up and they try to unmove blockers. So that's kind of the framework that everything else operates within. And then in the instruction, we use something called IY, which is called I do, we do, you do. So all of the instruction is an instructor will introduce a new concept, he'll program something in it, and then you'll program something along with the instructor, and then you break off into a group and you do it again, a different project, but on your own. And everything that we do is kind of a recursively larger or smaller, depending on how you look at it, IY loop. Every lesson is 3 or 4 of those. Every day is 3 or 4 objectives that are built into those kind of lessons. Every week is a bunch of units. And then every 5th day, we have what we call project day. And that's where you take all the objectives that you're supposed to learn in the previous 4 days, and you build those into a project. And if you can't complete that project, we have mastery progression, where you basically roll back and repeat that week again, form a new cohort. And then, similarly, every 5th week is what we call build week, where if you're in the front end section of the curriculum, you'll pair up with somebody in the back end section of the curriculum and somebody from the computer science section, and you're all building an application based on what you've learned. So throughout the course of Lambda School, you're basically building 6 full applications on teams working with different sections. That's really how it works. Yeah.
It's really cool. Where can people learn more about, where to go to get information and to maybe apply?
Yeah, lambdaschool.com. Lambda is spelled with a B, but no matter how you misspell it, we'll redirect you to the right place. We own all those domains. Or you can follow Lambda School on Twitter, or me, I'm Austen with an E on Twitter.
Actually, last question. Why Lambda? What's the name?
So we started out teaching Haskell. And so it comes from the Lambda calculus, which is, and then tried to change the name a bunch of times and just couldn't find a good one. And it got stuck. So it is what it is.
Well, Austen, thanks so much for coming in. We really appreciate the time.
Yeah, thanks for having me.
And now it's time for our Advice to Entrepreneurs segment. And this one, we're going to talk about product development specifically, and this idea that you can do things good, fast, and or cheap, but really only 2 out of the 3 at a time. So we've kind of talked about this a lot, but what are the stages, Phil? Like, what are the components of this? When can you do something good and fast, or fast and cheap, or is there a place where we can do all 3?
Well, I think you kind of said everything that needs to be said in the setup to this.
Shit.
When you want to build something, you could do it at high quality, meaning good. You can do it quickly. You could do it inexpensively, but you can never do all 3. And at most, you can try to optimize for 2 of them.
What about Five Guys?
The hamburger place?
That's great.
Yeah, so like Five Guys, you don't actually have to be able to achieve any of these things. You could be, bad, slow, and expensive.
No, it's so good.
They just give you like
and
a greasy
and pretty cheap
grocery bag of fries.
Yes, it's amazing.
I think this means this refers not to the product itself, although it's interesting to see how it maybe applied to product. It's how to develop. So I don't think Five Guys was actually developed very cheaply. The chain, the actual business, the franchise. It's probably a relatively high budget thing, but I don't know. I actually don't even know if any of this applies to fast food.
I mean, the whole concept of good, fast, and cheap makes me think of like sort of fast casual dining, right? It's like that is what they're striving to be, all 3 of these things. And I think in general, we can all agree that most of them suck.
Like Chipotle.
Right,
Yeah.
exactly.
Yeah, so basically, if you're building
Accurate.
something, the stuff that we have the most experience with would be tech products.
You mean not fast food?
I wish we had more fast. We should do an All Turtles restaurant of some kind.
No, we shouldn't.
Yeah,
Stay in our lane, folks.
If you usually when you're starting out, if it's literally just you and a co-founder or something, haven't raised any money, don't have much capital, usually don't have a choice. Like you have to stay in the cheap side. You just don't have money to not be cheap. So then it's just a question of like, well, what's more important? Is it making a high quality product? Is it or is it making something quickly? And sometimes one is more important than the other. If you're going for something that's like, if the product is meant to be very experiential, then you really have no shortcut to just making it good. Like there's a couple of things that we're working on at All Turtles that like their innovation is they're going to take a process that used to be very unpleasant and just make it a lot more pleasant. And if that's the value proposition, like you can't do it that half-assed. Like it has to be pretty good before you can even get any kind of a real test about whether or not people will use it.
Or if you're dealing with a very sensitive experience.
Yeah, exactly. Yeah. I think like with Spot, when we were working on Spot, like you had no choice. We couldn't release something even in a test that wasn't already like pretty good.
Mm-hmm. So it would really mess with people who had already been messed with.
Yeah, exactly.
But in the case of Spot, now there are also competitors. And, we've applied more resources to this project because it's going well. But that might mean, increasing speed on certain things or spending more money on certain things.
Well, with Spot, we very specifically chose good and fast and gave up cheap. Like Spot was not a cheap
No.
development. We invested a lot in it, a lot more than I think like we would have been able to. It had just been a raw startup because we used a lot of resources to get that done. So yeah, because we said it has to be good quality, but it has to get to market relatively quickly. So it's not like we spared no expense, but we definitely spent a decent amount on it, as opposed to something where, let's say you're starting out and you've got like a novel new idea and you just want to sort of test if it works, but it doesn't have to be particularly polished. Then maybe you can optimize for cheap and fast and get rid of the quality because you just want to get some early testing done. So it really depends on what the product is, what you're trying to optimize for, and it changes in the lifetime of the company. Even big companies will often say, well, our marginal economics are now more important than they've ever been, so we have to go for cheap. And cheap may be, hundreds of millions of dollars or more, but like cheap in terms of the actual unit economics per transaction. They have to try to start lowering the cost of it because, they have to actually get to profitability. So this is not even something that startups face. This is something that, like, this triangle, the good, fast, cheap triangle, is like a fundamental one at every stage of the company. And it's not like you like pick a place on it and stick to that for 20 years. It's going to be something that you constantly reevaluate.
Unless you're Five Guys.
Yeah.
In which case, everything you're doing is perfect.
So today's listener question comes from Derek on Twitter, actually. Thanks, Derek. This is a question about the personalization episode on the Unscaled series. And the idea is that greater personalization will always be better, but the marginal benefit will keep going down. So he says the bottom line is, will 20 milligrams of X work? And yes, but if 15.52 milligrams will work better and reduce side effects or chances of some kind of dependency, he would take that. So what do we think?
What?
Right.
Sorry, Derek says what?
I think Derek's asking a question about, well, we've talked kind of at length on personalization and whether or not
it's bullshit or not.
It's even a thing.
Yeah,
and whether you're really just bucketing people into a couple of different like tiers that you've predetermined ahead of time.
Right. So this is like a granularity of personalization question?
I think he brings in kind of like a macroeconomic theory with marginal benefit.
Right.
And he's just saying like the end user would acquire more benefit by having a more specific thing. And that sounds relatively true. And I think he's looking for us to evaluate just like what are the problems with this? Because I see a bunch. Like personalization in general, I don't know any good examples that are live in the world that aren't marketing or e-commerce or consumer economy based. And I don't know if any of those are actually good. It's like interesting, but I don't know if they're good.
Right. Yeah, well, in the pharmaceutical example that he gives, I'm assuming this is some kind of a pharmaceutical example, is interesting. And you can kind of trace the development of cures and therapies. And, the world went through this, the industry went through this massive phase over the past couple of decades where the future was all going to be in like hyper-personalized medicine.
Mm-hmm.
Like you weren't going to take a pill. There was going to be no like single pill. Like there would be 7 billion different types of pills because each person in the world would have a pill that was exactly customized to their specific environments. And that approach had some really startling successes early on with certain types of cancer. And then everything stopped. Like basically that approach turned out to work well for like a very small number of certain types of diseases, but like not at all, like it hasn't really led to that much ever since. And in fact, now most of the thinking about like population level health is, yeah, there's certain things that are very specific to, your genetics and other stuff, but the world is suffering from, diabetes and obesity and those related things. And that's like more or less the same for everyone.
It's just habits.
And the behaviors aren't that different.
Yeah.
Aren't that customized. I think that the episode that Derek refers to was a really good one. I actually think people should go and listen to the whole Unscaled series. This is where I talked with Hemant Taneja and Rhonda Scott about Hemant's new book called Unscaled. I went into that conversation thinking that personalization was kind of bullshit, that it was just an overstated marketing gimmick. Hemant had a much more thoughtful take on it, which is, he kind of said, the businesses in the past operated based on what he called the atomic unit of supply, meaning the product assortment that a company would offer would be based on what could they economically manufacture at scale. Mm-hmm. This is like the Harry Ford famous line, like you can have any model, you can have any color Model T as long as it's black. Like, yeah, sure, people may have wanted green Model T Fords, but it was like Ford couldn't make them economically because the whole production line could only make one thing. And what's happened now is things have shifted from the atomic unit of supply to the atomic unit of demand, meaning that now products are made not based on what can the company make economically, but based on like what is the most meaningful cluster of customers of demand that they need. So rather than there being, one diabetes drug, which maybe is like what you can manufacture at scale, like it's just insulin, everyone gets insulin. There's going to be maybe 20 different types because it turns out there's like 20 sensible categories of diabetes, but there's not going to be 7 billion because actually because of, I think as Derek says, the marginal benefits just go way down. So we'll see more personalization, but it won't be anything like individualized personalization. It'll just be, you will get bucketed in with some number of other people, but the size of that bucket is going to be determined by like what is most effective, what solves your problem the most, not necessarily like what can the company manufacture, because the idea is, companies really can manufacture lots of different individualized things. It doesn't cost them that much more anymore.
Well, I think it's a trade-off between greater population level benefits versus highly optimized personal benefits, right? So we're making the decision for the collective, right?
Right. And we're basically saying instead of like one big group, there's going to be smaller subgroups, but how small do those subgroups go? And that comes down to a marginal benefit issue, but probably not entirely a marginal cost issue, because it isn't so much that it's like, in the long term, it's not that cheaper for a big drug company to make, 50 variations of a drug versus 7 billion. Like they really could make with custom one for each one. It's just that like it would be much harder to test those. It would be much harder to figure out like what the interactions would be. It'd be much harder to actually know that they were benefiting you, because then what you have to do, like in effect, clinical trials on every individual. So it isn't just a marginal benefit versus marginal cost issue. It's really like a marginal benefit issue. And the more personalization you have, the less certainty the company can have to say that this product isn't actually harmful. Because if they're selling 7 billion different types of pills, they've clearly not tested each and every one. So even from just like what's good for the population, it doesn't go all the way down to individual level personalization for most things.
We keep talking about personalized medicine. Is there another good example of personalization that is demanded in the world that would be good? Because for me, I don't think it's like snarky or cart abandonment emails.
Are you sure?
Yeah.
It's a good point. There's probably a lot of personalization that's like harmful.
Right.
Like everything that has to do with just like selling you more crap is probably like at best a marketing gimmick, and at worst actually like bad for society.
Right.
Anything that's based on like feeding this idea of, you have, everyone is unique. You have your own personal magical tastes, and we'll use our AI stylist to like suggest your wardrobe. Like that's all nonsense. Not to say that everyone should wear the same clothes, although that would be such a time saver.
Yeah, like the Amish.
Yeah,
the Amish are very happy. They do a lot of.
That's a startup idea right there.
Oh no!
We have the room.
Someone needs to sell Amish fashions online, totally personalized to you. Everyone gets exactly the same thing.
It's a good idea.
It's a good idea.
Any gown you want, as long as it's black.
Yeah, someone make that and apply to all turtles. Thanks for the question, Derek.
This podcast is a production of the All Turtles Worldwide Media Empire. We recorded this episode in the world-class Donatella Studios in San Francisco, California. Thanks to Austen Allred for joining us this episode. If you have any questions, comments, or suggestions for future episodes, send us an email at hello@all-turtles.com. Marie reads every message. Thanks to everyone who made this episode possible, including Jim Metzendorf for editing, Marie McCoy-Thompson for production supervision and editorial management, Chris Plug for his audio expertise, Micah Rivera for our artwork, and Matt Ammerman for our theme music. On behalf of Jessica Collier, Phil Libin, and yours truly, John Cifuentes, and the rest of the All Turtles team, thanks for listening.